Welcome to our monthly webinar series, and this is the January edition. We hope 2025 is off to a great start for all of you. I'm Artur Kara. I do product marketing here at VMRay, and today I'm joined by my brilliant colleague Patrick Staupman. Hello, Patrick.
Hi. Hello.
Patrick is leading the threat analysis team in VMRay Labs, and it's great to have him in this webinar again. So for those of you joining us for the first time, these sessions are all about staying up to date around malware and threat detection, and we will share our perspective to the threat landscape. And every month, we dig into the latest updates from our labs team, discuss emerging threats in the landscape, and explore techniques used by attackers. Now, I would say with a heavy dose of technical deep dives. And we aim to keep this conversational, so very much like a podcast for our community. No jam-packed slides, just technical insights, demos, and ideas to take back so that you can take back to your teams. And we would like this to be a two-way conversation, so feel free to drop questions or observations in the chat. We love to take those at the end. Also, a quick note, this webinar is being recorded for those of you who cannot join, to make it available to reshare with your friends and family. So we'll share this recording afterwards. So we have got just around 30 minutes, so I would like to get started without further ado. And here is what we got lined up today. With Patrick, we'll start with an overview of the new VTI, so VMRay Threat Identifiers, to those of you who are not familiar, and how they work. And we will dive into the YARA rules we added recently for some of the, let's say, most talked about malware. And after that, we'll cover updates to some more detections around phishkits, for example. And finally, Patrick is going to run through sandbox samples and analysis reports and share insights on what they are up to. All right, let's kick things off with the first VTI we are highlighting today. This one is centered around DLL Halloween. So quickly, for those who might not be familiar with this one, and this is totally normal, this is a technique where malware loads an unrelated DLL file and hijacks its memory region instead of allocating its own. So once that's done, it writes its shellcode into the DLL's memory space and executes it. So this is categorized under the MITRE tactic T1055, which falls into the defense evasion category. And now, based on our analysis, Patrick is going to shine more light on it, but the VTI score for this is 2 out of 5. So it's kind of a medium to low priority detection, but still important given how it is often used by loaders like hijack loader, for example, to install payloads of Infostealers such as Luma. And it's also seen wine loader, for example, in an APT campaign, APT29, aka Cozy Bear. So with all these, so after this summary, actually, I'd like to turn to Patrick. Patrick, I would like to get your take on this around what stands out to you, and are there any patterns, behaviors you think the analyst should watch for? So.
Yeah, so I mean, you already did a great job and you nailed it pretty much. So essentially, DLL hollowing is just another technique of, let's call it process injection, whereas some shellcode is being injected into the current process, right? So we're not currently talking about remote process injection at that point. But as you've mentioned, there is just a process being executed and the process loads an unrelated DLL. Of course, we see specific DLLs being used quite often or quite frequently, but it can in theory be any DLL that's being loaded into the current process space. Then there's shellcode being written into this DLL, and then the execution is just transferred over to that DLL, to that module in the current process. So you may actually wondering why we're going to have this with quite a low score, which is a 2 out of 5, which in theory just flags this as suspicious. And that is due to a specific process that we're going to use here. So whenever it comes to adding new detections that are being able or that are supposed to detect the sample as malicious, that's of course also a bit dangerous, right? You never really know when you release an update. It can in theory cause false positives as well. So we usually follow here a two-step approach or a two-step process where once we have finalized and finished the VTI and the implementation side, we essentially release the very first stage of that with a lower score. In this case, as you can see, it's a 2 out of 5 score. Then we just let this run for 1 or 2 weeks and just ensure that we don't observe any false positives and just really correct and intended trigger conditions. And once this has been confirmed, then we are basically going to increase this to a higher score. So in theory, you will likely see in a couple of weeks, 1 week, 2 weeks maybe, an increased verdict of that VTI that's also supposed to directly raise this to a malicious score, because in theory, we're just talking about process injection in a different way. And yeah, that's just to be transparent here. That's a way on how we can ensure we provide the best and accurate detection mechanisms to our customers, while still also ensuring we are not causing any false positives and can ensure everything is working as expected here. Well, I think that's being it so far. Back to you, Ertu.
Amazing, Patrick. Some really great insights there on how we can look at the VTIs. So moving on, before we continue with the other VTI, actually, we wanted to share a practical detection opportunity related to hijack loader that we just mentioned. And credit goes to the great work done by the team at Red Canary here. And they have identified a detection analytic for spotting renamed instances of auto IT, which is commonly used by the likes of hijack loader. So those renamed binaries might appear in unusual locations, or they may have seemingly random names in their path. And we have found this insight from, again, Red Canary to be incredibly useful, and recommend checking out their blog. Also, we'll find those in the resources slide at the end, so we're going to share this. And in that one, they have outlined the top 10 threats from last month. So it's really useful stuff. So great to love to see more of these. And the next one, let's move on to the another VTI. This one is a bit different because it's not about files, but web analysis. So specifically, SVG files are being used in phishing campaigns. And these became pretty popular toward the end of last year. And we've given this behavior a VTI score 3 out of 5. And just a bit around how it works. So it starts with an SVG file attached to the email that has JavaScript code inside it. So this code is used to make web requests. And when you open it, you will see a blurry Excel PNG image and a phishing form, for example, asking for credentials. And one of the actually not so interesting tricks is that the email address on the form is hard-coded. And based on that email, actually the logo in the top right corner changes dynamically. So this is kind of the magic coming with, again, JavaScript. And this happens because they are using a logo API from Clearbit, which is a marketing platform. Now we have a specific VTI for this one, so that's the summary. Patrick, do you have any thoughts, anything to share around this?
Yeah, maybe there's one thing you have mentioned, that they are actually dynamically adjusting this logo, and this is something that we have seen, well, now already quite a while, but I think it's also getting more and more popular, that they are really trying to present some sort of branding information that is already really directed towards the target, right? So for example, if you put in here your email address from VMRay, you will likely also see the VMRay logo that's being loaded here, right? And I believe this is very, very dangerous. Maybe not explicitly for this here, well, even though it's already risky, but especially if it comes to the logon form from Microsoft, right? Microsoft also, and I guess all companies usually know that, they're using branding information, right? So if you log into Microsoft Office 365, you put in your email address, you will get this branded big background image that is loaded. And this information, unfortunately, I would even say, is also usually available to threat actors or to phishing actors in that case. So they can basically try to take the email address, try to query some APIs that are being exposed by Microsoft, and then they're essentially really loading this complete branding mask for your email address. And I really believe that this is very risky, because that really, at least to me, it often feels like it's just trying to get trust from the user that is essentially entering the email address. And from my point of view, even worse than this one here, where I see an Excel document or an Excel background, right? Just seeing the legitimate Microsoft logon page with your branding information, even though that's a phishing page, I believe this is really, really risking, and something that we have to watch out for.
Yeah, thanks for your insights again. I think it is kind of increasing the believability from my perspective. Cool. So, I mean, regarding SVG, so just one more slide. So this is kind of really new item on our list of threats, and want to speak a bit more about it. So on top of course, leveraging sandboxing, automated tools to inspect emails, you might have some other options. So this is just what we just wanted to share this. So blocking SVG files outright might seem like the obvious move, but it's not always practical for businesses, for example, relying on SVGs. I mean, doing some design stuff, for example, some CAD or some other design. This is something probably used often, like technical drawings and maybe marketing. So it can be tricky to implement without disrupting operations. And some people joke, actually, this is why we can't have nice things. So because we are blocking upright. But on the flip side, SVGs, they are powerful really enough that they can be a real problem if users make the wrong judgment call. And here are a few things to consider. So if you can block SVGs, great, do it, but make sure it doesn't hurt your business processes. And the second thing, look at setting up email rules that can detect and flag suspicious SVGs, especially during the download. So also you can stay engaged with community. So platforms like, for example, Mastodon, and they are great for discussing these issues and finding best practices. I'm dropping a link here if you are curious to learn more about what community is discussing around this. So now let's move on to the YARA rules section. These additions actually play a critical role in helping us classify malware samples more effectively, and also to detect different versions within the same malware family. And we would like to start with CryptBot. For those unfamiliar, so it's a Windows Infostealer around since 2019. It kind of had a big moment last year. Actually, not last year, 2023, when infections rose to millions of devices. And Google got involved with a court order to take down its infrastructure, and it was successful. So the numbers dropped to 40,000. But as often happens, CryptBot hasn't disappeared. And throughout 2024 and recently, actually, researchers observed new variants and domains being registered and used as CryptBot C2s, as well as to distribute its payloads alongside other stealers like, again, Luma. And again, with these developments, we have created YARA rules to better detect and classify CryptBot variants. Patrick, don't know if you have noticed any specific trends around this, but I think we are used to kind of comebacks, but I think this is pretty quick. Like towards the end of 2023, a takedown happened, but 2024, early 2024, we have seen a comeback and kind of continue to be trouble.
Yeah. I don't know. I believe that this seems to be quite often a trend nowadays, right? It's not only with CryptBot that we have seen that they're getting takedown and then they are reappearing. I believe that's also for other malware families that we have tracked in the past, right? We've talked a lot about Bumblebee that actually was part of a big takedown and then it reappeared a couple of months later again. So, I mean, we all know takedowns are important and relevant, But of course, there's the risk left at the end of the day that operations are getting restarted from the ground. So I believe it's valid. I don't really want to spoil anything here, but maybe we will hear something about CryptBot again in next month's iteration of this webinar. Maybe we have some more updates and insights to share, but let's keep it like it is here and not go deep into that one.
Okay, no spoiler. Right, great. So again, before we move on, I want to take a moment to give a shout out to the community, specifically to Malbeacon, for their excellent work on credential stealer formats. They put together a great GitHub repo that's kind of a catalog of formats used by stealers for capturing system information, that one of which you can see on the slide. There are also YARA rules to help, like the one on the slide here. So using key details like username, local date and time, operating system, the RAM and GPU, and all of that, that are kind of common in the system information logs of CryptBot and others. So feel free to check out this repo if that sounds interesting to you as well. Next up is another one, VIPKeylogger. And I mean, as its name suggests, this one records keystrokes on top of typical stealer capabilities. And maybe it sounds familiar, probably because it shares many similarities with Snake Keylogger, which has been around for some time. And based on the recent research around this, what we can share is basically attackers are using mail spam campaigns with attachments, like it can be a zip file, an Excel, a PDF. So, and these documents typically contain downloaders that use PowerShell to fetch and execute the keylogger. And what makes recent campaigns particularly interesting is their use of legitimate services. For example, attackers have embedded malicious images hosted on archive.org, so web archive. One of the images had been accessed about 29,000 times. So suggesting these campaigns are really can extend to pretty widespread. And the exfiltration and stuff, so I'm sure Patrick is gonna touch on those during the demo, so I'm not gonna go too much in detail. But to give you a better idea of the social engineering tactics at play, here you can see also some example file names used in these campaigns. So banking receipts, purchase orders, quotation. So as you can see, I would say lack of creativity, if you're familiar with these. And moving forward, so to wrap up the VIPKeylogger section, so we pulled together some recent IOCs related to this malware family, including C2 addresses and exfiltration URLs. So as well as you can see here, some links to our public thread feed, where these IOCs actually were observed in action. So now, if you have been following our sessions over the past year, you might have noticed a bit of a threat intel twist in our content. So actually that's intentional. We see it as a natural extension of what we are good at, threat analysis, detection, that sort of thing. We want this time to give you as much practical value as possible. And aligning with that goal, actually, we have been working on a new threat intelligence suite. That's kind of a spoiler, but I'm allowed to share this one, Patrick. It's currently in testing with some of our customers, and we are running an alpha program. So you can expect more insights from us, from VMRay, around threat actor activities in these webinars. So stay tuned. All right, before I pass it over to Patrick, here is a quick look at what other YARA rules we have added. So we have added YARA rules around some phishkits like SRJ, blur, and so one of which is leveraging JavaScript, dynamically assembling the final page via a sequence of functions. And the blur, as its name suggests, featuring a blurred background of Office products, so it looks like believable. And last but not least, concatenated zip, very mouthful. So for me, so two zip files kind of created, merged by the attacker to hide the malicious file. in one of them. Now, Patrick, I think I missed an update around malware config extractor still, but anyway, I will leave it to you. So please take it away. Then we will be back together for Q&A. But
yes, I believe I can cover that one. So well, now let's actually go a bit into the practical part here and look into a analysis report that is coming from VMRay platform. And as Ertuğ already mentioned, there was a bit of a spoiler on threat intelligence direction, and of course also into a TI feed project that is going on. We all know that a proper malware family detection, classification, as well as high quality IOCs are very important for these cases. So we have recently also, in this case, let's take the example with VIPKeylogger, focused in adding additional detections for this specific malware family. We see here the VMRay analysis report. That's basically what behavior that we observed during the execution of a file that we're going to record here, and then basically present here in a report for very easy and quick understanding what is going on here. We see, well, at the first place here, it's quite obvious. It's a malicious sample here. We have the classification as spyware. We know it's keylogger, it's a stealer. It's probably collecting data and exfiltrating them. And we have the threat name here, which is VIPKeylogger. There are some additional variants here, likely coming from external services like reputation or AV detections. And if I'm not mistaken, I believe VIPKeylogger is also called, or there's a similar word for that, which is not found keylogger. But usually it's well known as VIPKeylogger. Yes, and taking a look here into the VMRay Threat Identifiers that Ertuğ already covered before, it's just a information and a score on specific behavior that we can observe during the execution of the specific malware in a safe environment. We can see here, we have plenty of them triggering. I will just cover them in a second. If you go a bit further down here, we see some malware configuration being extracted, even some screenshots to see what is going on. We see process graphs to have a very quick and basic understanding, the MITRE mapping here, of course, and finally some meta information. All of these details, this is just the high level. We can, of course, go deeper here as well, but all of those details in this case are being extracted in just 5 minutes. Well, 5 minutes is not the default value here. So usually we capture everything in the default analysis timeout of 2 minutes. But of course, that depends a bit. Usually everything that you want to have is there in 2 minutes. But if you want to go deeper into an analysis report, if you maybe want to observe if there's something else that is coming at a later point of execution, you can just increase this analysis timeout during the submission how you want to. And in this case, we've just selected 5 minutes because we want to do a bit of a deep dive into this family here. When looking here into these monitored processes, usually you probably would expect you see a sample start and then you see some process being executed. We even have some memory or some process injection here, and that's basically it, right? But in this case, it's even more interesting because we somehow also see another part of this graph here that indicates a reboot has happened, right? Well, reboots are not really usual for malware, I would say, right? So malware usually doesn't really trigger a reboot on the system, but we do it with a specific reason. If malware tries to get or to establish persistence on an infected machine, which means that whenever it should survive reboots, if like the user is going to home in the evening, he's shutting down the machine, starting this machine on the next day, then of course a threat actor still wants to have access to this machine. And that's why they usually try to get persistence. In this case, there is a remark message here at the top of the analysis report that indicates an automatic reboot has triggered due to the sample installing a startup script or a task for an application for persistence. And I believe this is very important and relevant. And if you want to look deeper into that, you can even go to this VTI section here. There's this persistence VTI. Then we can see that the process number 2 attempted to add, well, something that seems to be a Visual Basic script to the Windows startup folder, meaning whenever the system gets rebooted, this script is going to be executed. And then, of course, you usually see pretty much likely the same behavior as we have seen before, right? So threat actor is getting persistence here on that machine. We have talked about YARA signatures before, right? So we have recently, in recent months, introduced a new YARA signature that's supposed to detect the VIPKeylogger payload. In this case, in its already unpacked plain format when it's being executed in memory, right? So you see here, it's actually triggering in the memory dump from process number 2 and also from process number 8. Right? So if you look down again here, we see it has been captured already in process number 2 and in process number 8 over here. But you may wonder, why not in process number 3, right? Well, that's kind of difficult to explain sometimes, but one of the usual behaviors on why this hasn't been observed here in this process is usually because of the reboot that has been triggered, right? So maybe at the time before the payload has fully been injected, the reboot occurred. But of course, that's the reason why we, at the end of the day, have this reboot to see what is happening afterwards. With having this YARA match, we of course also being able to identify this as VIPKeylogger, which means we also can execute our malware configuration extractor for VIPKeylogger, which means that usually malware comes with embedded details information that usually either enrich some information that is being needed by the malware, or it even can somehow describe a bit of behavior that the malware might do during the execution, right? It can have some specific flags being set, like you do this or do that, right? But the minimum required information usually is the command and control server, which is usually called, also known as an IOC. That's very, very relevant if it comes to TI. And in this case, VMRay config extractor for VIPKeylogger here, if we just go down, extracted this malware configuration that's usually obfuscated and or encrypted. So we are finding this location where this is stored, and then of course we are extracting this, we are decrypting all this information, then present it here nicely in the analysis report. But of course we also have this in the analysis archive in a JSON file format, so that it can either be very, very easily accessed and automatically further processed. Before I quickly want to cover this one here, let's actually go back here to the VTIs, and we have mentioned keylogger is a stealer. So we have a VTI here that's actually raising this core immediately to malicious that indicates data collection. It seems that the sample is trying to read cache credentials or other sensitive data, in this case here of a couple of applications, Google Chrome, Internet Explorer, Edge, so a couple of browsers, and even Microsoft Outlook. And of course, for keylogger, for a stealer, it's usually that this behavior is, should be there, right? And if you go further down here, you can even expand some of those VTIs here, and you see a more detailed description on what is happening, right? So in this case, you can see here a bunch of different browsers going from Google Chrome over, what do we have here? Brave, we have somewhere Internet Explorer, Firefox. So lots of different browsers are being targeted here to just search if they're being installed, and then try to exfiltrate sensitive data of them. Could be credentials, could be cookies, could be maybe even some other information that maybe you can extract from browser extensions and so on. Same thing here. We have for mail data. In this case, Microsoft Outlook is being targeted, and also Thunderbird, just to find if this application is installed, and if yes, extract sensitive information such as usernames, credentials, and so on and so forth. One very interesting highlight, I believe, here is also the usage of direct system calls. We actually spent lots of time in the last year, in 2024, to look into direct system calls and also indirect system calls. And the goal of using this is just to make monitoring-based solutions that are relying on hooking blind, right? So instead of just following the usual Windows API on how you should go from the high user level all the way down to the kernel level, they are just directly making use of system calls in the application itself. So from the application, they are directly going to jump into the kernel and then trying to execute those functions. That just means that whenever there is a hook being installed, either on user level of those APIs, maybe even on the native level, those hooks would be useless because everything is just simply bypassed by using direct system calls. On the other side, if you have a bit of internal knowledge and you understand how that works and how that operates, the detection of direct system calls is essentially quite easy and not really complex at all. So it can be very easily detected. And it's usually something that you would not expect in a legitimate application. Well, of course, we have plenty of other VTIs triggering here, really describing the behavior that the sample is doing. That really helps you a lot in very quickly getting a good understanding of what is happening here. So before we wrapping this up, I still want to quickly focus on the extracted malware configuration that is very important if it comes to threat intelligence data. So in this case here, we see this is keylogger version 4.4. That's just part of the encrypted config, of the embedded config. There is an encryption key, which is, yeah, well, that's the key here, but we also extract the algorithm. So essentially, if you find this blob of encrypted data inside the binary, that's the keys in the encryption algorithm that you need to decrypt them. Why is it here? Well, we still believe that tracking VIPKeylogger sample or other samples, it's very useful if you have the key, because then you either can select or find maybe samples from similar campaigns or from the same campaign, because they usually make use of the exact same key. Then we see the URL here to a SMTP server, which, as Arthur mentioned before quickly or briefly, is the VIPKeylogger makes use of different ways on how to exfiltrate data. SMTP is one here, as the mail server being specified. Of course, there have to be some credentials inside the sample that the sample is used to when it's connecting to the mail server, that it can authenticate itself. And then, of course, there also have to be a recipient, which means that once this data has been collected and it needs to be exfiltrated, that the sample knows, well, where do I have to send this email to? Basically, that's supposed to be the operator at the end of the day. And in this case, we actually have another command and control server communication channel here, I would call it, which is Telegram. Telegram is a very popular and quite known instant message service that's cloud-based, right? And there's a very interesting observation we had over the past month, actually even years. Instant message services like Telegram or even Discord are getting more and more used. They're getting more and more popular by threat actors for establishing command and control server communication. So we spent a couple of time in thinking on why is that, and there are a couple of good reasons why threat actors might even go with Telegram here in that case. So first of all, well, SMTP is kind of legitimate, it's fine, right? FTP is another option, but not really that legitimate. I believe it's not that common that you maybe see lots of FTP traffic nowadays. But at least for Telegram, this communication is usually very legitimate. Nearly lots of people are having Telegram installed on their phones, so there's lots of traffic to the services, right? And now we have two different options, right? Threat actors could either say, well, let's build our own command and control server infrastructure. So just setting up like hosting services somewhere, buying servers, getting IP addresses, running their own software for a command and control server communication. That's one option. But of course, that requires usually credit card. Then you maybe need to have some VPNs or proxies so that you can hide your IP address behind that, right? Otherwise, it might be very easy to track down who is operating that service. If they are going with Telegram, then they usually have way less pain points they have to come through, they have to get through, right? So it's a cloud-based service that is already hosted, right? They don't really have to care at all about hosting. They don't have to build up a server. They don't have to maintain that server. They only need a phone number to be able to register to Telegram, and then essentially they can use it for free, right? And that's, I believe, a pretty good argument to use that. Then they can just create bots there, they can create group chats, and then they can just play around with that. What is essentially also what we see here, then you basically have a bot. This bot requires something like an API token that you can interact with that bot, right? And a chat ID. And what you see here is basically if data is being exfiltrated, or well, maybe just this infected system registers by the operator, then they just need the bot ID, which is the ID, and of course then the token for the bot, and then the chat ID. And what is going on then is that VIPKeylogger is just writing a message to this group chat here and saying, well, I don't know, we haven't looked into how this message format looks like, right? But I'm registering here as an infected host. Here is the data that I have collected, right? So that's a simple way of communication here. But of course, we also have seen in the past that this is being used as a bidirectional communication. So it's not only the bot that can send chats or messages into this chat, but also the operator can send messages into the chat that are regularly being checked by the bots. And then they can read that, they can interpret that, and carry out specific actions the threat actors want to have, right? So you can say, well, maybe make a screenshot, send it to me, right? Or just download this additional payload, execute it there. So there's lots of things that can happen. from a threat actors or from a threat researchers, like from our point of view, from a defender's point of view, this is actually valuable information that you can use to track down specific operators. You can find clusters. You can even find maybe operators that are using multiple different malware families. So we just recently looked into one of those Telegram bots here, whereas the bot name was indicating something VIP snake, whatever, right? And there I believe you also have a bit of relation, what Erto mentioned before, VIPKeylogger, snake keylogger, right? So there's close relations, and maybe threat actors or operators are even using both of them together at the same time, infiltrating different hosts, but just having one Telegram chat where all of them are actually communicating with, right? You could find samples that are being distributed by the same operators based on the ID here, based on the bot token, based on the chat ID. And there's also plenty of other open source intelligence topics and stuff that you can do here, right? It's an API of Telegram. You basically have the token here, so you can also play a bit around and do some tracking on that side. And yeah, that's important information. And due to the malware configuration extractors we have here, it's also very easy then just to track those operations down here and following them to also ensure you can have you have good insights, good visibility, and can protect your environment. With that being said, I believe we are coming close to an end here. And Ertu, I will just pass it back.
Perfect. Yeah, Patrick. Again, great insights, great demo. So I would like to, before we wrap up with Q&A, so I would like to share our resources that we have mentioned today. I mean, there's a great community out there, so we can't say it enough. So we will also be sharing these slides in the follow-up email, so keep an eye out. And now let's open it up for Q&A. Again, thanks to everyone who has been active. So some of the questions I already typed answers in the Q&A part, but the first, so I will do my best to moderate this while Patrick probably takes the lead in answering. So the first question, Patrick, how can we best map the data? I think it's around the threat intel, but the data from VMRay reports with the sticks format. I think that's a quick one.
Yeah, so essentially we are providing the sticks report, and there are lots of automated systems that you can just basically take those reports, they consume them, and they present them in a pretty nice format to you. But I believe VMRay, so we are providing the sticks reports, and that's essentially containing the most valuable IOCs and information that you need for doing threat intelligence and also hunting.
Amazing. So the second one, how do you deal with false positives from sandboxing detections? Do you do adjustments to YARA rules? Also, I think it would be worth mentioning the IOC side of, false positive issue.
Yeah, of course. So, I mean, there's multiple different approaches that we are following here to ensure we have the lowest false positive rate and we actually can provide. So first of all, of course, we do our own research. We do submitting also a bunch of files internally, collecting results, evaluating those results, ensuring that we have the best detections, highest true positive rate without ending up with any false positives. But on the other side, of course, we are also very happy to take feedback, either from customers, from prospects, from people that are looking into our published reports, right? If there's something that you came across that's saying, well, that doesn't really look correct, maybe it's a false positive, maybe we missed some detections, then we are taking this very serious and of course react as fast as we can on that to ensure we can improve the quality of our analysis reports.
Brilliant. So that was it, kind of the question part. So I think that's all we've got for today. Hope this was really useful time spent. So a lot going on in the world, and we appreciate you joining this webinar really. And feel free to connect us on LinkedIn, and we are always open to feedback or contribution. And we wish you all a fantastic start to this year, to 2025. And we hope to see you back here for our next webinar on February 25th. Until then, take care.